So today we're going to talk about functions, like what are functions or how do they work or something like that. So functions is actually an extremely important part in both math and computer science. Like once you understand like the basics of functions, then it should be pretty good to go from here, because actually function is like an extremely important building blocks in both math and computer science. So in this video, we are going to talk about functions and computer. I'm going to split the entire video into these parts. So without further ado, let's go. So before immediately diving into the math definition of what's a function, we're going to use an analogy in this case, which is being used by my high school textbooks, which is actually a pretty good one. So here we go. So imagine out of nowhere that we have a blender. Yep. Took me a while to make this from blender. So, oh lord. Okay. Anyway, oh boy. Okay, so imagine we have our blender, and then let's just say we put our apple into it. What we will have is apple juice from the blender in this case. But other than apple, can we put in anything else? Yes, we can. I've decided to put in orange. And what you will get is orange juice. Now, other than oranges, you can also put other stuff, like you get the idea. I can also have lemonade in this case. So, lemon, put it in there. You have lemonade. So yeah, as you can see, the blender will just take in some input and then give you something out. So yeah. So the function is actually almost the same thing. A function takes an input and give you something else. So in this case, in most textbooks, they will also explain what is a domain or what is a range. So the domain is actually like a set of elements or a set of objects such that a function can accept to process on it. Like for example, for a blender, the domain is the fruits, like the lemon, like the apple, whatsoever. Now, this also means that some of the functions cannot exactly always accept everything. Like for example, if any one of you dare to put a B plushie into this thing and blend it, I'll come find you. But yeah. And then of course, this also moves on to range. What is a range? A range is like another set such that the function can produce or return. Like in this case, the range of the blender are the juice in this case. Like you're not going to like expect the blender going to give you a pencil, or the blender is just going to give you a box out of nowhere when you put a watermelon in it. That does not make sense. So yeah, so that's the domain and the range. Okay, so with all of that stuff, we have the analogy and then we have the concept. Now we just have to like learn like how to write them. So let's just start off simple. We can give our function any name, but most of the time it will just give them a single letter name. Like for example, most of the time we just call them f whatsoever. So here we have that. So, and then the next thing is we have our parentheses. So what this parentheses does is just like saying, okay, this whole thing over here is our inputs. And then of course you can name our input anything you want, but most of the time we call it x. Okay, so this is the very classical way to write function f of x, whatever. But you can write it in any other way. Like for example, if you decided to call your function g and then it takes an input y, right? No problem at all. Like heck, you can even call it different ways. Like for example, another very classical example of functions is trigonometry functions. Maybe you saw them before. Like they call the function sine or sin, and then they take the input theta. Like see, this is also a function as well. So actually there are many ways to write it, but most of the time we're just gonna say it's a f of x whatsoever. But they can, you know, whatever. Okay, so let's have a mathematical example. So this is a valid function that we have. So over here on the left, we have our f. So the f is like our blender, which takes an input, which is the x, like our apple, and then it gives us our apple juice over here, 2x plus 5. So in this case, we have that. So let's try what will happen. So when we put in 3 as our fruit, okay, whatever, watermelon, let's say. So what will it give you? So over here, x is 3. And then you just go plus 5. And of course, you will have 11. So that is what the function will give you when you give the number 3 to it. So f takes in 3, gives you 11. So that basically how it works. So sometimes we can have like multiple functions act as a chain, but here's the problem. Different orders of functions will cause the result to be different. So for example, you first blend your fruit or whatsoever, and let's just say you add ice. Although this is not ice, but pretends it's ice. So what you're going to have is you're going to have a nice juice with ice cubes in it. Pretty good. Alright, but what if we just switch the order? We first add ice along with the fruit, and then you put it into the blender. What you're going to have? You're going to have a smoothie. Where did the ice cube goes? It got blended. So as you can see, both function are applied, but in a different order, and of course the result is different. Okay, so let's quickly look at a mathematical example in this case. So, for example, okay, I'm going to use the red one just for declaration. So let's make two functions out of nowhere. So, like, let's say we have f of x is 2x. And then we have our g of x is x plus 5. So in normal human sense, it would be something like what f does is it doubles the input and give it to you. And then what gx does is it add 5 to it. So let's take a look at this in action. So in this case, like for example, let's say we start with 3. Okay, if we put it to f first, we will have 6. And then put it through g, we would have 11. Okay, pretty cool. But what if we do the same thing but in different order? Like we first put it to g, so we would have 8, and then put it through f, we would have 16. So as you can see, different orders gives you different results in this case. So yeah, composition, you have to keep that in mind. It's really important in this case. Okay, so sometimes if you just like go even a little bit of like deeper, you can find the word inverse or inverse of a function. So what's that? So basically an inverse of a function is a function that does the total opposite of the original function. So take our blender example. So a blender takes a fruit, blend it, gives you the juice. So the inverse function of the blender would be something like you take the juice, you put in it, somehow it turns into the fruit and give it back to you. So imagine we have this like magical black box, whatever it is, okay? What will it do? It takes the fruit, gives you the no. It takes the juice and it gives you the fruit back. So basically the main idea would be something like you put the lemonade inside, it gives you the lemonade, and then you put the lemonade into the box, it gives you the lemon back in this case. So yeah, so that's the inverse function. Now, here's the thing. Not exactly every function has a inverse function. So that's one of the things. Like, I'm going to quickly give you a very good example in terms of math in this case. Okay, so, all right. So assume that we have this function. Let's see. So let's say we have f of x is x mod 5. So basically this symbols, okay, although this looks like percentage, but in most of the programming languages, it means modulation. Basically, it just do something like take x divided by 5 and then give me the remainder. So basically, it goes like, or maybe, okay, maybe not 5. Maybe not 5. You know what? Let's go for 3, which is actually much simpler and easier to see like what's going on. So let's take a look. Here we have in, and then we have out. So here's our function in and out table, if you can see it over here. So let's see what will happen. Yeah. So just put 0 in it. Okay, it gives you 0. Cool. Put 1 in it, gives you 1. Put 2 into it, gives you 2. Alright, seems pretty fine. And then you put 3 in it. Oh, gives you 0. Okay, for now it works fine. You put 4 in it, it gives you 1. Okay. Now let's just pause here, okay? Now here's the question. Can you find a function such that it will accept 0, 1, or 2, and then it will give you the original number back? Now, some of you might realize, oh, it cannot be done. Why? Okay, if I give you 0, the original source might be a 0, might be a 3, might be a 6, or a 9, or a 12. Like, from the standpoint of a function, it cannot guarantee that the number I give is the original number in this case, because I only know it's a 0, but it could be 0, 3, 6, or whatsoever. So in this case, this function over here do not have a inverse function, so you have to be careful with that. All right, and so yeah, we have that. So basically, that's all you need to know about functions, basically. So let's just quickly wrap it up, like what we know about functions. So basically, a function takes an input, gives you an output, and then what it can accept is what we call the domain. What it can produce is what we call the range. And then of course you can chain those functions up, and then this is what we call composition. But keep in mind a range of those functions will also change the result in this case. And then yeah, sometimes a function have a inverse function, but sometimes a function do not have an inverse in this case. So yeah, that's basically all the things that we need to know in this case. Alright, thanks for watching. See you in the next episode.